So we'll have a Q&A session.
I'm wondering about combining the map, sorry, the density improvement, with the combined focused maps. Is it possible to somehow use both of those tools? And if so, in what order would you recommend?
That's a good question. So, I didn't really talk about combined focus maps here, but basically combined focus maps is a way that you can use. You can take a set of maps that has a set of models matched to those maps already, and use the local correlation of the map to the model in each map to identify how good the map is there, and then to weight the maps, then superimpose all the maps based on where their models are, and then weight the maps according to how good the maps are. So that's what combined focus maps will do for you. Yeah. And then the question is, can that be used along with density modification? So I would say combined focus maps would be the last step in something like this, that you would not probably benefit anything by density modifying a combined focus maps, because that map has so much information from different things merged together in a totally more or less random way. I don't think there's any way that density modification can separate out those errors and figure out how to optimize the map. So that would be the last step, is combined focus maps. So then the question is, what's the best thing to go into combined focus maps? And there the answer would be, yes, each individual map, you would want to optimize that map to make the part of it that's the good part be as good as possible, whatever method you can. So sharpening, local sharpening, whatever it does, whatever makes that part of that focus map be the best possible, that's what you want to do. And that could include, yes, density modification of the focus map, where you adjust your parameters in such a way that the part that gets better is that focus part, and you don't pay attention to the rest of it. And I've never done that, but it seems like, for example, changing the boxing or changing the resolution might affect whether the focused part of that map gets better or not. And that would just be a little bit of experimentation about how to do that. So yeah, I'd encourage you to try to do that, yes.
Can I ask a follow-up? Do you have some feeling for what the mass or the sequence should be that we provide then if we have a masked focused refinement? Should it be only the mass which is within the mask?
Yeah, I don't know the answer, but here's my guess, is that if the whole map is pretty good and the focus part is really good, put in the whole thing, just like a regular density modification. If the most of it is like almost not there and the focus part is the good part, then put in just the focus part. That'd be where I'd start.
Okay, and just play around with it from there. Thank you.
Yeah, if you do that, Bonnie, let me know, because I've never tried it.
Okay.
I'm just guessing.
Thanks. I will do.
Okay, great. So it looks like maybe this hand raising feature is not available to everybody. We'll try and debug that for next time. Maybe it's a Zoom version issue. So if there are other questions, why don't you start your video up and just physically raise a hand like this, and we can see you, just like Bonnie did. And don't be shy.
See, I do see one question.
In the chat, yes.
Yeah, in the chat from Ibrahim. Are you there? I can try to answer it. Oh, let's see, the question is, explain best strategy for icosahedral viral structures. And do you box the half maps or the combined map in density modification? So I would say the best strategy for this is you have two half maps, just supply those half maps as is to resolve density modification and supply the molecular mass of the whole thing. And that should work pretty well. If you wish, you could trim down the map to be just a little bit bigger than the virus itself, maybe 10 or 20 angstroms on the sides, and then don't box it inside. The only reason you would do that, well, the main reason you do that is because that would make it smaller and might make it a little bit quicker. Also, if Resolve doesn't box it properly, you might try that. But basically, you would just throw the 2 half maps in, give it the resolution, and say go. And the molecular mass, and say go.
Right. The other questions. Oh, okay. Prince has a hand raised. What's your question, Prince?
Yeah, hi Tom, thanks for the talk. So I'm a kind of beginner in this using Phenix. So today I saw that the Resolve Clarium or the density improvement option is added recently to the 1.18 of Phenix version,
Yes.
right? So my question was the auto sharpening and the density improvement. Can we switch the order of the performing the two? Like, can we do the density improvement first and then do the auto sharpening? Because sometimes while doing auto sharpening, we see the continuity we lose the continuous segments. So can we perform in another way, like first doing the density improvement and then the auto sharpening?
In principle, yes, you can do that. What I would say is, so density modification automatically does some auto sharpening. Now, at the end of density modification, you have a map. And it may be that some blurring or sharpening of that map could improve its clarity. So yes, it's perfectly fine to carry out probably not the automatic version of map sharpening, but rather a model-based map sharpening or a trial and error map sharpening where you blur it by 10 angstroms or sharpen it by 10 angstroms, look at it and decide which one you like. So those things are fine things to do. I'm suggesting not the automatic version that I described where it looks at the map and tries to make the clearest one. That won't work very well because the solvent has been flattened. And that's part of the procedure, is looking at the amount of noise in the solvent, but you've minimized that with density modification, so it won't work very well. So adjusting the sharpening of a map after density modification is a perfectly fine thing to do, and adjust it more or less manually, or use model-based sharpening to decide on that sharpening factor. That will work well too. And in fact, if you carry out density modification with a model, the final map that you get is sharpened in exactly that way. It is sharpened using the model at the end. So yeah, very good question.
So I have one follow-up small question. So I couldn't actually understand the basis behind the density modification. Like, since we don't have any data here, so how do we modify the density based on, what is the basis of density improvement?
I'd say the fundamental basis of density improvement is that we know that the solvent region, for example, is relatively flat.
Okay.
And that if we change the Fourier coefficients representing the map so as to make the solvent more flat, that reduces errors in the Fourier coefficients. And that makes the protein region more accurate.
Okay, thanks, Tom.
Great. So anybody else going to raise their hand for a question, either visually or electronically, or type in the chat? There was a lot of questions during the talk, so maybe we got to all of your thoughts.
So if I can ask one more question.
Sure.
So about the auto sharpening, actually I recently worked on a map resolution at 4.5 resolution map, and I used the auto sharpening option. So there I found that there are some areas which got improved a lot, like we can see when the side chains very nicely. But some regions, they're very fragmented, like we cannot see the continuity of the map. So how to use the auto sharpening, because we are losing the density in those regions. So how to use this thing in a better way? Like, can we like manually put something, because it's automatic thing, auto sharpening. So can we manually do something where we do not lose the density for the other region?
So if you see some region that gets worse with auto sharpening, that would be a candidate for the thing that I said I don't think really works very well, which is using local sharpening. So if you turn on the local sharpening option, then it will look in each part of the map and try to figure out the sharpening that's best for that part of the map. So that would be an option in this case. Also, if you used a model-based sharpening, you can also do that as a local sharpening option. So it is possible.
Okay, and at any point during deposition of the map, we are going to deposit only the reconstruction, the map obtained from reconstruction, not any of the modified map, right?
I would disagree with that. I would deposit all the unique special maps that you create, whatever they are. So if you create a density modified map and you use that for something, I think you should deposit that density modified map. If you sharpen a map, it's less crucial, but I would also deposit the sharpened map that you use to build your model and refine.
Because in the density improvement, we are seeing a significant resolution improvement, right? Like roughly 0.5 angstrom. So can you mention that improved resolution?
So yes, you can mention, I would always quote what program told you a certain resolution and what that number was. And then that will mean something to somebody. But if Resolve Cryo-EM improves your map, if its starting resolution says 4.5 and final is 3.5, you're welcome to say that, but that doesn't prove that the map is all that much better. And people won't necessarily just buy it that this means the map is 1 angstrom better. What will convince them is showing them the picture of the map. This resolution and what is my resolution, it's a really big problem.
Yeah.
Because in X-ray, at least you have, resolution is also a big debate, but at least I collected data to X resolution. At least people know that's what I collected. Doesn't prove that you have information to that resolution. In Cryo-EM, it's not that well defined. And in particular, once you've made modifications like carrying out a density modification, it's just not well defined what the number is. But a person who's experienced can look at a map and you know what you can see in that map, how defined it is. And that's what, to me, is what's really critical.
Because at some point we need to mention a number, like a global resolution. If you're going to mention the improved resolution, they're going to ask, like, how did you determine that resolution? Like, did you use the 2.5 maps or all the processes they're going to ask? So that's why I was asking. Yeah.
Yes, and so if you use Resolve Cryo-EM, I would say that the value Resolve Cryo-EM reported, and you could type that phrase that's in the output is this number. That doesn't say that's what the resolution is. It's just that's what Resolve Cryo-EM says the number is. And
okay. But still, the global resolution will be the same, which we got from the Reliant, right? using
No,
the-
that number would, oh, you're welcome to report that as the overall resolution, that's fine. And, but the effective resolution may be a little bit better, and you can report that if you want. Yeah.
That's, thank you very much.
Okay, any other hands raised? Quick question from Francisco. Is there a tutorial within Phenix that goes through the whole process from checking your data to getting a final model? I see many small tutorials, but somehow disconnected. You're muted. Tom.
Yeah, we don't have that. We don't have a all the way from beginning to end thing. And yes, there are many small ones. The one that's density modification model building goes all the way from 2 half maps to building a model and correcting it. So that one does a lot of it. But the checking your model, that's M-triage, separate tutorials for that. Yeah, so we're working on that. We don't have a complete beginning to end.
Correct. There is, those of you that looked at the documentation, we do have like a flow chart for both crystallography and cryo-EM. And if you click on each of the boxes, that typically will go through, will tell you about the various steps, and you can look at the tutorials for those. But yes, we don't have something that steps through everything. And partially that's because often it isn't just one step after another. You do things in between, maybe in a different, in Qt, or so it would be great to have something that just ran automatically from the data through to a final finished model, but we're not there technology wise. But you're right, we could try and make something a bit more integrated.
I have another quick question.
Yep, Bonnie?
Related again to the combined focused maps, would it be valid, do you think, to include half maps and then to calculate a global FSC on the basis of the half maps, the combined half maps that you get, or is that going too far?
No, so Bonnie, I put in an option to do that a couple months ago, actually. So yes, you can, the way you do this is you run combined focus maps just like now, and then you add in, these are my half maps that correspond to those full maps. And then whatever it does to the full maps, it does the same thing to the half maps. And then you end up with a combined focused half map that has the exact same properties as the full one. And you could do whatever you want to analyze its characteristics, yes.
So you think that an FSC based on comparing those half maps would be a sort of valid?
Yeah, I think it would actually be, and you could even box, some particular region and do an FSC, or mask it or something in some. Yeah, actually, FSCs with masks are always problematic, but you could mask it in principle, and get the FSC in a certain region based on the for the combined focus map. Yeah, you could do that.
Okay, thank you.
Actually, just let me expand on that comment just for 1 second. So if you mask something that causes correlations, if you have to have 2 half maps and you mask each one, the correlation between those maps now has changed. It's generally higher than it was before. You can partially get around that by masking with a soft mask, and that's an option in Mapbox.
Okay, so I'm not seeing any other questions. And it's 11:30. I realize it's getting later in the day in Europe. Oh, there's another question.
Recordings? When will they be available?
Well, I don't know, is the short answer. We have to see how big this file is, and we have to probably maybe chop it into pieces a little bit to make it more manageable. So it might take a little while to do that. So we'll try as quick as we can. But
somebody hinted on the. I'm sorry, Paul. Somebody hinted on the chat that when you have used Zoom to record to the cloud, that Zoom will actually distribute it for you.
Yeah, so I've done this for my class earlier in the year after we all started teaching from home. So yes, I can just share a link to this. So that's one option. But I think we also want to look at maybe tidying this up a bit. But yeah, we can just share the raw link, but I don't know what size this is going to be. That's the other thing. And maybe chopping it to pieces will make it a bit more manageable for people, because the ones I did earlier in the year were often quite large. So if it's feasible to just put the link up to have people look at it, we'll do that. But we may also take a bit of time to tidy it up. So we'll try and do it as quickly as we can. There's a question from Anna. I've seen Rosetta and Eraser tools for crystallographic data. Can we use these for cryo-EM? Would they be used after map to model? That's a great question. So we're very interested in integrating more of the Rosetta features in collaboration with Frank de Meyer, for example, into the cryo-EM case. They built tools for cryo-EM themselves. Right now, we don't have that. So there's something we want to work on, but right now we don't, unfortunately. And Eraser needs a bit more work on the Eraser side to be more usable generally. So that's a work in progress. But yeah, you could imagine that some of the Rosetta tools would be a nice intermediate step between initial model building and then, say, refinement. Trying to improve the model. The combination of Rosetta and Phenix Refine for crystallography is actually very powerful at low resolution.